Hi guys, this is Areldan Calamba. So this is another discussion before our sample problem. So let's start. So this is another video for our sample problem. So this is the last set for our unit vectors or for our vectors as a whole. Okay, so problem number 5. By the way, this should be sample problem number 4. Okay, so find the scalar product of vectors A and B and B and C. So you have to do the scale dot product of A and B and B and C. So you have here an illustration of our vectors. You have here A, B, C, and D. So we're just after A and B and B and C. So for all we know, we have these formulas for our scalar product. Okay, so you have there A dot B is just equal to AB cos phi, and then you have A dot B is just equal to AX BX plus AY BY plus AZ BZ. Okay, so let's have the first one. By the way, this is very easy. When we're dealing with dot product, they are very easy, essentially easy compared to the cross product. Okay, for A dot B, we're to look for A dot B. So just have to consider these two vectors A and B, and that's it. So I have illustrated that one. So there. So find the scalar product. Basically, it's just the magnitude. It's a scalar quantity. So A dot B is just equal to the magnitude of A times the magnitude of B times cos phi. That's why we have 8 times 15 cos 150. But what is that 150? For all we know, we have to deal with the smallest angle between the two vectors if we're talking about cross or dot product. So you have there 210 and then you have 150. I hope you already know how did I get that 150 and that 210. So A dot B is just equal to negative 104 meter squared. So meters times meter squared. Next is for the dot product of B and C. So two vectors again. This is your B and this is your C. You have two angles here. And then we have to take note of the smallest angle. So this should be that one. Or by illustration, we should be using 145 degrees. So B dot C is just equal to 15, the magnitude of B, times 12, the magnitude of C, cos 145. And we got negative 147 meters squared. That is now our dot product. Example number 6. So find E, find vector E, that's just equal to vector D cross vector C. Find F, that is equal to A cross D. And G, that's just equal to C cross D. Okay, so same illustration. You have 4 vectors there, A, B, C, and D. So for the vector product, for all we know, we have this one, A cross B is just equal to AB sine phi n hat, wherein n hat denotes for the direction. And we have the other one using the matrix, okay, using the basket method. So for this one, if we have this kind of illustration or this kind of vectors wherein we're already given the magnitude, it is better for us to make use of the first one, that is AB sine phi, and then get the vector product. But if you have it in terms of components, or if these vectors A, B, C, and D are in a component form, then we go to the second one. We will be using the matrix. But this one, as we all know, it is in terms of magnitude. Hence, we will be using AB sine phi. So let's have the first one, the vector E. That is just equal to vector D cross vector C. So let's illustrate that again. So you have this one, vector D and vector C. Vector D, vector C. We have to connect them tail to tail. So we have to make use of the angle between them, the smallest angle between them. So that is 62 degrees. This one. So in terms of magnitude muna kukunin natin. So that is 10 meters times 12 times sine 62. Wherein we have the magnitude of D cross C, that is just equal to 17.7 meters squared. But for the direction, because we all know that it should have, if we're after a vector product, it should always have a direction. This is only the magnitude. We don't know the direction yet. But using the right hand rule, we could we could actually easily get the direction of our dot product. Always remember that our cross product. Always remember that our cross product is always perpendicular to the plane where our two vectors are located. So this one, our vectors D and C is just in two dimensions. You have their x and y. They are present in the x and y. So the perpendicular the perpendicular component of our again. So our vectors D and C are just located or being positioned in the xy plane. And for all we know, the perpendicular plane for x and y is either in the positive z or negative z axis. Okay? So, or plane rather. So this one, we have the idea now that if it's just two dimensions or it's just in the x and y plane, the cross product rather of d cross c is just in the negative z or positive z axis. So using the right hand rule, this one, right hand, wherein we just have to put this one to the first vector, that is the vector d. Okay, and then we easily curl wherein where our vector is going. So it's coming from vector d crossing to vector c. So let me just flip my camera because it is mirrored. Wait lang. Ayan. Sorry. Para right. Okay? So, it should be coming from vector D. So, this is coming from vector D, ha? So, coming from vector D, going to vector C. So, that's, this curve is actually pointing towards vector C or going towards where our angle phi is being measured. So, from D, going to C. And then you have your thumb. That thumb will direct you to the direction of your cross product. This time, the cross product of D cross C. So, coming from D, going to C. Huwag na yung going to the other way. Okay, this is the wrong way because this is not the smallest angle. This should be the smallest angle. Okay, so D cross C. The thumb is pointing towards you, pointing towards me. So most probably the vector product is going out of the plane. So if I'm going to be technical about that one, if I have it like this, so I have positive y, positive x. So this should be positive z. So D cross C, it should be going to the positive z axis. Or pwede na ako dito out of the plane. Okay, so vector E now is just equal to 17.7 meters squared k hat. Okay, that's our cross product of D and C. Okay, the second one wherein we have A cross D. So, going kay A, papunta dapat kay D. We have the magnitude of A and then the magnitude of D. So, you have that one. So, getting the smallest angle phi. This. So, that's 127. So, mathematical operation AD sine phi. So, that's 8 times 10 times sine 125. So, the magnitude of A cross D is just equal to 65.5 meters squared. That's the magnitude. But for the direction here, you could see into the plane or negative z-axis. Okay, let's go back here. So, coming from A going to D. Huwag nyo pahirapan ang sarili nyo na maghanap pa kayo ng paano ba ito i-curve. You just look at the vectors and then the angle phi. Okay? So, galing kay A. So, ito. Galing kay A. Pag ganyan dapat. Pupunta ka kay D. A going to D. So, your thumb is actually pointing away from you. It is towards the plane, towards the monitor. So it should be using this convention. It is going to the negative z axis. So that's how we will make use of our right hand rule. Now, for number 3, you have to look for vector g that is just equal to the cross product of vector c cross d. So you can see the answer here is negative 17.7 meters squared k hat. I want you to solve for this one and use the right hand rule in determining the direction. And you compare it with the first one. That's with the first one here, d cross c. And make some comparison wherein why the magnitude is like that, or why the direction is kinda different, or it's in the opposite direction. So you do you compare and then you analyze. Okay, so why it is such that way. Okay, let's now have sample problem 7. This is kinda different now. So problem 7, vector A has a magnitude of 12 meters and vector B has a magnitude of 16 meters. The scalar product A dot B is 112 meters squared. What is the magnitude of the vector product between these two vectors? So the magnitude of the vector product. So you have to cross them. So you have to get the cross product A cross B. Just the magnitude though. So A cross B, the magnitude is just equal to AB sine phi. But for all we know, we are given just the magnitude of A and B and the A dot B. There's no way for us to cross. Okay, so it's kind of difficult at first glance, but it's very easy actually. Okay, just you have this one. So solving for phi, we have to solve for phi first because we have to get this one. Okay, so we have to get for the angle between our two vectors because we already know A and B, but we don't have the direction. But we could get the angle phi using the dot product. Okay, so solving for phi, A dot B is AB cos phi. So arc cos is just equal to the magnitude of A dot B over AB. So that's 112 meters squared over 12 times 16. Using your calculators, you'll get the angle between the two vectors, and that is 54.3 degrees. Okay, so we now have the direction. Not the direction, sorry. We now have the angle between the two vectors. So we could easily solve for the angle between our two vectors A cross B. Sorry. We can now solve for the magnitude of A cross B. We can now solve for the magnitude of A cross B. So A cross B is just equal to 12 times 16 times sine 54.3. So, sorry. This should be 156 meter squared. This is now our answer. Okay? We now go to the last problem, sample problem A. So find C that is just equal to A cross B if A is equal to 3i hat minus 4j hat plus 4k hat, and B is just equal to 2i hat plus 3j hat minus 7k hat. So it's kind of easy because we already know this one. So vector C is just equal to A cross B, and I don't want to use the memorization, the familiarization of the formula. I will use easily the matrix. That's easier. Okay, so using this one, I hat, j hat, k hat, and then copy the first two columns and then paste it to the end. So you do now down minus up. So down minus up. Okay, so we have negative 4 times negative 7 I hat plus, kasi nasa down pa tayo, down, plus 4 times 2 times j hat, this one, plus 3 times 3 times k hat. Okay, that's one. Minus, and then quantity. Minus, going up, 2 times negative 4 k hat, this one, plus 3 times 4 times I hat, this one, plus negative 7 times 3 times j hat, this one. And then you you could distribute this negative sign inside. Okay, so all the positives will be negative, all negative will become positive. Okay, so negative times negative rather will become positive. So we now have this one, 28 I hat plus 8j hat plus 9k hat plus 8k hat minus 12j I hat plus 21j hat. Combined all the like terms, we now have a cross b, that is just equal to 16i hat plus 29j hat plus 17k hat. Okay, so that's for our sample problems. I hope you have grasped all the sample problems properly, and then you could now start answering for the problem set for this for this topic. Okay, so see you sa next topic. Bye.